Have you ever tried to install something in your machine and it works and the world is amazing and full of light and joy, but then you realise that it broke something else and the world returns to the murky darkness that you've grown accustomed to? Ever set up some software on a server and realised you'd broken something so badly you had to format your entire computer and start again? I know I have. Docker was invented specifically so we never have to deal with that nightmare again. But what the heck is Docker? Welcome to Foxy's Lab. I'm Foxy, and in this series I explain complex smart home, IoT and home lab concepts in a way that makes sense. In this episode we're talking about Docker, the tool that's basically the backbone of every modern home lab and probably more than half the internet. So, go grab a coffee, I'll get one too, and then we'll get into it. Docker is a platform for running applications inside lightweight portable containers. Think of a container like a self-contained box for a piece of software. It's got everything that an application needs to run. The code, the libraries, the dependencies, even specific versions of system tools. You package it all up and now it runs exactly the same way, whether you're on a Raspberry Pi, an old laptop, a dedicated server, or even in the cloud. No more reinstalling your entire OS just because you broke something whilst trying to get one new service working. Just clean, isolated applications that don't step on each other's toes. Here's a quick history. Docker was publicly released in 2013. It was created by a company called DocCloud, which later renamed itself to Docker Inc. The man behind it was Solomon Hykes, a French developer who was fed up with the age-old problem of, well, works on my machine. Before Docker, if you wanted isolation between applications, it was possible, but you had to use a virtual machine, which is heavy. Each one needs its own operating system, which eats up disk space, memory, and takes a lot longer to boot. Docker took a different approach. Instead of virtualizing entire computers, virtualized just the operating system layer using something called Linux containers, or LXC, which funnily enough is the subject of the next video in this series, so don't forget to subscribe so you don't miss out. Docker initially used LXC under the hood, but later moved to its own container runtime to give them more control over the whole stack. By sharing the host OS's kernel and isolating just the application layer, Docker made containers fast, lightweight, and incredibly efficient. Within a year of launch, Docker exploded in popularity. It became the foundation of modern cloud infrastructure, development workflows, and most importantly for us, it became the absolute cornerstone of home labs everywhere. Like every other good tech tool, Docker comes with its own vocab, so let's break it down. A container is a running instance of an image. It's your actual application running in isolation. Containers are ephemeral by default, so stop one and any changes inside are just gone unless you've explicitly saved them. An image is the blueprint for a container. It's a snapshot of everything your application needs. The OS base, the application code, the config files, and any dependencies. When you install, say, Frigate or Node-RED, you're pulling an image from somewhere and then running it as a container. A Docker file is a script that tells Docker how to build an image. It's written in plain text and describes each layer. Install this, copy that, run these commands. Think of it like a recipe. You follow the steps and out pops ready-to-use image. A lot of home lab users never need to write Docker files because we're usually using images that other people have already built for us, but it's useful to know what they are, especially if you're a nerd like me that likes building their own services. A registry is where images are stored and shared. Docker Hub is the most popular public registry. It's where you'll find official images for things like Home Assistant, Mosquito, InfluxDB, and thousands of other applications. When you pull an image, you're just downloading it from a registry. It's worth noting that not all images on Docker Hub are well maintained. Stick to official images or well-known maintainers when you can. Random images from unknown sources can be abandoned or unsafe. You can even host your own registry on your server. This is often useful for organisations who want to keep Docker images accessible to everyone internally, but don't want them to be publicly online. Or even just developers who want to keep an internal repository of apps and services. A volume is persistent storage for containers. Remember earlier how I said containers are ephemeral? Well, volumes let you keep data outside the container so it survives restarts, updates, or complete rebuilds.
It's not safe in here.
This is crucial for things like your Home Assistant configuration, your Frigate recordings, or your database files. Anything you don't want to lose, basically. Technically, volumes can be Docker-managed volumes or simple bind mounts to folders that are already on your host. Many home lab setups use bind mounts without realising that's what they're called. A network lets containers talk to each other, or the outside world.
Go out and meet people.
Docker creates isolated virtual networks, so your containers can communicate securely. For example, your Node-RED container can talk to your Home Assistant container without exposing every port in your entire home network. Docker Compose is a tool for defining and running multi-container applications. This is often useful in development scenarios where you want to run something like the backend services and your database. You can just run one command, Docker Compose up, and everything just starts. It's like magic. Orchestration is how you can manage containers at scale. Tools like Kubernetes and Docker Swarm handle things like load balancing, scaling, and automatic restarts across multiple servers. You probably won't need orchestration for a typical home lab, but it's good to know it exists if you ever want to go completely overboard with your setup. I may cover this in a later episode if there's interest, but this is as far as we'll mention orchestration for now. Honestly, Docker runs everything in my home lab. Home Assistant, Docker. Node-RED, Docker. Influx, Grafana, Frigate, Mosquito, Nginx Proxy Manager, all Docker. In fact, at the moment, every single service on my entire network runs on a Docker container. The beauty of Docker is I can spin up a new service in minutes, test it out, and if I don't like it, just delete the container. There's no leftover rubbish scattered all over my file system, I'm not dealing with weird dependency conflicts, and I don't get that horrible sinking, oh god, what have I broken this time feeling. Everything's nicely isolated. I run almost all of my Docker services through Unraid, which has a brilliant web interface for managing containers. I've done a what the heck is Unraid video if you want to learn more about it. Unraid makes it dead simple to deploy containers with just a few clicks, but under the hood, it's still just Docker doing all the heavy lifting. One of the best parts of Docker is that whether you're using Unraid's GUI, Docker Compose on the command line, or Portainer, or whatever tool you fancy, it's all the same containers running the same way. So if tomorrow I decide I don't want to use Unraid anymore, I could just move everything over to a new server without much hassle at all. Alternatives like Podman do exist, but Docker's still the most common choice because of the ecosystem and community support. That's the real power of Docker. It doesn't lock you into one way of doing things. I should mention that I also use Docker in my day job as a software engineer, and it's brilliant there too. It solves all of the same problems, but for development teams rather than for home labs. But for me, the real magic of Docker is what it's done for the home lab community. It's democratized self-hosting. You no longer need to be a Linux wizard to run your own services, you just need a server and the ability to read a little bit of documentation. I would actually go as far as saying that without Docker, home labbing would not be nearly as popular as it is today by a very large margin. If you're enjoying this episode, give me a like and hit subscribe. Are you using Docker in your home lab? What's your setup? Drop it in the comments, I want to hear what you're running. If there are any topics you'd like me to cover in a future What the Heck video, let me know in the comments and I'll stick it in the list. You can also find me on the Fox's Lab Discord server, where I'll be more than happy to answer any questions you've got, or just shoot the breeze if that's what you fancy. Link in the description. Alright, Docker is brilliant and makes life a lot easier, but there are a few things that can trip you up when you're starting out. Welcome to the gotchas. Fortunately, there aren't too many, so we can keep this section nice and containerized. Networking can be confusing at first. Bridge networks, host networks, Mac VLAN networks. It all takes a bit of trial and error to understand how containers see each other versus how they see your home network. For most home lab stuff, the default bridge network is fine, but some services like Home Assistant work better with host networking. If you want my advice, start simple and only get fancy when you need to, and don't beat yourself up if it takes a while for it to sink in. Or even if it never sinks in. I've been using Docker for almost a decade, and I still have to Google this stuff all the time. Permissions and volumes can be a bit of a nightmare. If you're on Linux, you'll eventually run into permission issues where the container user doesn't match your host user, and suddenly your container can't read or write its own data. It's fixable with user mapping or by adjusting permissions, but it's still annoying the first time it bites you. Containers are not virtual machines. They share the host kernel, which means they're faster and lighter, but they're also less isolated. Don't expect the same level of security or separation you'd get from a VM. If you're running something that needs serious isolation, consider running it in an actual VM or on bare metal instead. Not all smart home services work well in containers. Some services that need direct access to USB devices, like Zigbee coordinators, can be tricky to pass through to containers. It's definitely possible. I have a few containers that I pass GPUs and USB devices to, but it requires extra configuration and can be a bit fiddly. Similarly, some services that need network discovery can have issues in containerized environments. These are not blockers to success by any means, they just make the learning curve a little bit steeper. Docker can eat disk space. Old images, stock containers, unused volumes, they can pile up fast. The command docker system prune will clean this up for you, but be aware it can delete unused images, stocked containers, networks, and volumes, potentially causing data loss if you're not careful about what you're removing. If you're using something like Unraid, the GUI makes it pretty easy to spot and remove old stuff selectively before it becomes a problem. Either way, keep an eye on your storage, or you might wake up one day to a disk full error wondering where it all went. Containers without resource limits can be greedy. By default, a container can consume all available CPU or memory on your host. Docker lets you set CPU and memory limits, which matters especially on small home lab machines. Rule 1. Use Docker Compose. Seriously, even for single container setups. It's easier to manage, easier to document, and easier to share with other home lab enthusiasts. Plus, you'll thank yourself later when you inevitably need to tweak a port or add an environment variable. If you're using a GUI like Unraid, you don't need to worry about this bit. Rule 2. Pin your image versions. Don't rely on latest tags. They're vague and can break your setup when the image gets updated. Pin specific versions in your Compose files. That way you know exactly what you're running and updates can't jump out and surprise you.
I don't like surprises.
Rule 3. Use volumes for anything persistent. Configuration files, databases, recordings, logs. If you care about it, put it in a volume. Otherwise, it's gone the moment you delete a container.
That was a mistake.
Be sure to name your volumes sensibly too, something like Frigate Media or Home Assistant Config. That way you'll still know what they are 6 months from now. Rule 4. Organise your compose files. I keep each service in its own directory with its own Docker compose YAML file, but other people prefer one massive compose file for everything. Find a system that works for you and stick to it. Future you will appreciate the consistency. Rule 5. Back up your compose files and volumes. Your compose files are the blueprint for your entire home lab. Your volumes contain all of your actual data. Back them both up regularly, whether that's the Git, the cloud, or just an external drive. A good backup means you can rebuild everything quickly should disaster strike. I should point out that if you're using a web interface like Unraid, not all of these rules will apply. So that's Docker, the tool that turns "I spent 3 hours installing this" into "I spent 3 minutes installing this." It's fast, flexible, and honestly, once you get the hang of it, you'll wonder how anybody ran a home lab without it. What the Heck is an ongoing series where I explain the ins and outs of tech. I try to post a new video every week, usually on a Monday. So if you want to be notified when the next episode drops, hit the bell and YouTube will make sure you're kept in the loop. If you haven't already, go check out my What the Heck is Unraid episode. It pairs perfectly with Docker, and that's what I use to manage most of my containers. Or if you want to see Docker in action with some real home lab applications, check out my What the Heck is Frigate or What the Heck is Home Assistant episodes. You can see my entire What the Heck series right here. Ta-ra!